Okay, guys. So good afternoon, everybody. So last time I started to explain very important topic, as I told you, about interrupts. So I explained here and make a definition what I mean by interrupts, why they are very interesting. I can summarize all what I said in just one sentence. So interrupts means an event. There is an event. Okay, this event coming from somewhere. What do you mean by somewhere? I mean, just an example, it can come from different sources. Okay, but for example, it can come from a timer. So you have a timer system, you have a timer. I'm gonna ask the timer to interrupt me every 10 milliseconds, for example. So the event every 10 milliseconds, the timer is gonna make an event. You got what I'm saying? This is just an example. What do you mean by event? Another event, and this is similar to RTI, as I'm going to explain today, hopefully today or maybe next time. Also, we have another event. Maybe you have a pin here, and every time a falling edge come here, and this falling edge can come, for example, from a sensor. This can be an event. I'm just want to explain to you what event means, because this is event can be different. It depends on the source of the interrupt. So if the source of the interrupt is a timer, so the event here means time out. So for example, I can ask the timer to interrupt me every 10 milliseconds, right? So every 10 milliseconds is gonna trigger interrupt, or is gonna make an event. Okay. In another case, maybe I have a pin here, and I wanna trigger interrupt every time there is a sensor here, for example. Okay, so this sensor is going to sense something, like for example a train, as I said last time, and then it's going to make event. It's going to make event by making falling edge on this pin. Okay, so every time there is a falling edge, there is an event. Okay, for example, let me have another example. For example, if you talk about serial communication. Okay, so serial communication here, that means we have microcontroller that's connected to another microcontroller. That means you can send data from here to here, serial communication, right? So how I can know if already I received the data, or this microcontroller, how this microcontroller can know if I already received that data and it's ready for me to get it? Should I do like pooling, as I explained last time, pooling? Should I do something like pooling? Like I have to check. I'm going to ask the serial communication. Have you received anything? No. Have you received anything? No. Should I do that? No, we're not going to do that. Okay. What's going to happen? The serial communication itself, circuit, okay, is going to make event. Is going to trigger interrupt, or is going to make event to the microcontroller when it receives the data. So when it receives the data from the other microcontroller, it's going to trigger interrupt. So interrupt here means an event. It's going to tell me, I received the data is ready, just to come and take it. You got what I'm saying? So this is an event. So here I just want to tell you there are different types of events, because we have different sources of interrupts, as I explained before. Okay, but for all of them, they have events, as I explained, and every time there is an event, we have to serve. This event is going to trigger interrupt, and when you trigger interrupt, I have to serve the interrupt. So what do you mean by serve? What I mean by serve is I have to execute the corresponding subroutine. I have to execute the corresponding subroutine, right? So that means this source has a subroutine. Every time there is an event, I'm going to go and execute the subroutine, right? This source, serial communication, it has its own subroutine. RTI, it has its own subroutine, and so on. Is that okay? So if I just jump, here. So this all the sources of interrupts we have, as you see here, guys. So in this chapter, I'm going to focus on IRQ and RTI. Also, I'm going to give you communication, serial communication. But next chapter, we have timer system. Timer system can trigger 8 interrupts, as you see here, 8 interrupts. We have other things, as I told you. We have, I think, interrupt coming from analog to digital, and so we have different sources of interrupts. So for every source has its own subroutine. We call it ISR, interrupt subroutine. When this event comes, I have to execute the subroutine of this event. When this event comes, so I'm going to execute the subroutine, I'm going to serve This is the term we use, serve the interrupt. Is that okay? Anyway, so I can just define interrupts in just one sentence. Events, okay? This events, I'm not gonna write a code. No, this is not coming from a code, right? And because of this events, every event, I'm gonna suspend the main program, as I mentioned before. So we're gonna suspend the main program. So for example, as what you learned so far, I have to execute this one, and then this one, then this one, this one, this one, then this one. Okay, this is true if there is no interrupts. However, if there is interrupt, for example, comes here, so after executing, I'm not gonna suspend the execution of the current instruction after I finish. So once the microcontroller starts to execute an instruction, okay, what happens if interrupt came right now and I didn't finish? So I'm gonna serve the interrupt after I finish this instruction. Okay, for example, in the middle of executing this instruction, I got interrupt. Okay, so I'm not gonna check the interrupts until I finish. Okay, so once I finish this instruction, so next time I'm not gonna move to this instruction. I'm gonna go execute a subroutine and then come back. So the idea is not difficult. It's similar. The idea is similar to calling subroutine. Yes, it's similar to the idea of calling subroutine. However, when you call subroutine, you have to use instruction, jump subroutine, in order to execute subroutine and come back. Here, the calling come from the hardware. Here, the calling come from the event. Is that okay? Anyway, so I told you also last time that interrupts you can maskable. That means you can enable or disable interrupts. Okay, so what do you mean by you enable interrupt, or you here instead of enable disable, you can use the English word mask. So you can mask an interrupt. Anyway, so you can enable or disable. What do you mean? Very simple, very simple. If the interrupt is enabled, if it is enabled, that means every time there is an event, again, I'm gonna serve it. Serve means execute the subroutine. Very simple, right? So if it is enabled, if you disable interrupts, if interrupt is disabled, if you disable interrupts, that means if there is an event and you trigger interrupt, I'm gonna ignore. What ignore means? Ignore means I'm not gonna execute the subroutine because it is disabled. Is that okay? Okay, so now the question is, how can you enable interrupt, or how can you disable interrupt? And why sometimes I need to disable some interrupts? Why? I'm gonna tell you why. For example, I want to do something like for example, I want to do for example, police alarm, or the alarm I explained. You remember the alarm I explained in chapter 3 and so on. Okay, so what I did in chapter 3, guys, I want to give you example why sometimes I need to disable interrupt. I'm going to tell you why. Okay, just one example. So for example, there is some emergency, okay, fire, whatever, some emergency. So now I want to turn the alarm on, right? So what we did in chapter 3, the alarm, I put it in the main program, okay? You remember when you generated a square wave in the main program, you can do it differently. You can generate the interrupt, for example, using RTI, timer system, using a timer, okay? So for example, you're gonna have a timer every time, for example, I'm going to ask timer for every 10 milliseconds or so. So every time there is a trigger, I'm going to generate a square wave. Okay, so the alarm now is done by RTI. Okay, guys, RTI again, it's a timer. It's a timer. This timer should generate periodic interrupts. Once I ask the timer, please trigger me every 10 milliseconds. So periodically, every 10 milliseconds, as long as it is enabled, as long as the interrupt is enabled, so periodically every 10 milliseconds it's gonna trigger interrupt. Okay, now assume this alarm is generated by this interrupt or RTI, for example. Okay, and now there is no emergency. So now I want to stop the alarm, right? So the way I can do it is I'm going to disable RTI interrupts. Very simple. Why? Because who's generating this one? The interrupts of RTI. Okay, so this is like alarm is a task. This task is going to be run by RTI. So if I don't need this task anymore, what should I do? Disable interrupts of RTI. You got what I'm saying? So that means because you disable the alarm, you disable the interrupts from RTI, that means the subroutine, it's not going to be executed. That means there is no alarm because the alarm here is done by the code you wrote in the subroutine. You got what I'm saying? So let me make it simple. Every interrupt should do a task, certain task. So if I don't need this task, what should I do? Just disable this interrupt. Okay, that means you are not going to execute the subroutine. That means this task is not going to be run. So now I'm gonna explain how can you enable or disable interrupts. I told you last time we have two levels. We have this level. This is, as I told you, this is like a master key. This one can disable all, but it cannot enable all. Can only disable all. How? As you see here, guys, this is the flag register. One of the flags, we call it register I here, as you see here. So if you put here one using this instruction, set I, or using this one, I didn't try, I'm not sure if this one is working or not, but I'm sure this one is working. So you can simply use this one. Okay, this is one for set, this one for clear. Okay, so if you put here one, that means all the interrupts are disabled, all of them. Okay, however, if I put here zero, okay, that means now it doesn't mean if I put here zero, it doesn't mean all of them enabled, but it means now I'm gonna move to the next level. And in the next level, as I told you, every interrupt source has a bit to enable or disable this bit. Okay, guys. So now, in order to enable an interrupt, number one, you have to put here zero to enable all interrupts. Is number one. Number two, you have to enable the interrupt of this source. Okay, and when I explain any interrupt source, I have to tell you where is this bit. Very simple. It's a register. This register has one bit for enable. Okay, and then I'm gonna tell you have to set or you have to clear. And we already know how to set one bit in the register or clear one bit in the register. Okay, to enable or disable. So this is the way you have to think about every interrupt source. I'm gonna tell you there is a byte. This byte has one bit. Using this bit, you can enable or disable this source. Is that okay? One more thing I want to tell you guys. When the way this board is communicating with your laptop is using SCI0, this one, serial communication, right? So serial communication, and this one, serial communication, needs interrupts. Okay, so if you disable interrupts, for sure the board is going to lose communication the board is going to lose communication with your laptop. Okay, because you use serial communication. So if you disable interrupts, it's not going to be able to communicate. Okay, so that's why I don't think we're going to do it, at least for a while. Anyway, so okay, so this is the first thing. So now, here I'm talking about programming. How can you program interrupts? As I told you guys, it's very easy. Why? Because if you understand how can you program one source, all of them are the same. All of them are the same. The only difference is, for example, for a certain source, I'm going to give you a register. I'm going to tell you this is a bit for enable or disable. For another source, I'm going to give you another register and maybe a different bit for enable or disable. That's it. But you have to do the same steps. You get what I'm saying? You have to enable. So still one bit here, but just you need to know where is this bit. This is the only difference. That's why if you learn how you program one source, all of them are the same. Okay. So anyway, so in your programming, in your code, guys, if you when you program interrupts, number one, you have to make sure the first instruction you have to use CLI. Okay, so you have to use CLI because CLI is going to be used to enable. It's going to be used so that you can enable your interrupt, but also the local bit Again, here I put it like a switch, but it's not a mechanical switch. It's the same thing, but like a bit. So now, on top of that, the bit, this is initialization. So in the beginning of your program, you have to do this initialization. You have to do two things. Number one, CLI. Number two, the bit, the local enable bit. We call it local enable bit. You have to, as I'm gonna explain later, you have to enable interrupts here, okay? This is the first thing. This is number one, okay? So number one, you have to enable interrupts, okay? Then at any time, if you wanna, and that's what we're gonna do in the coming lab, I'm gonna ask you to disable interrupts. At any time, if you wanna disable interrupts, you can it's just one bit, just write 0, or I'm gonna explain it, write 0 or 1 to disable. I'm gonna tell you which one for enable, which one for disable. Okay, guys, any questions? Okay, let's move to the next part. The next part here is about how to request interrupt, how the CPU. So again, this is a story. We have CPU, we have different sources, we have different circuits, we have different sources, okay? How the CPU can know if there is interrupt or not, okay? Very simple, very simple. I'm gonna give you a very good example. Look here, guys. Now, I'm lecturing right now, right? If you wanna interrupt me, what would you do? Yes, that's true. You have to raise your hand to interrupt me, right? To grab my attention, okay? Same thing. But instead of hand, a bit. You get what I'm saying? So it's the same thing. Every device has one bit. If I want to trigger interrupt, this device is gonna put 1 here in this bit to trigger interrupt. Then once the hardware is gonna feel this one, it's like exactly like my eyes is gonna just notice that you raised your hand. Once the hardware is gonna feel there is one there, that means there is a trigger from there. You get what I'm saying? So this bit is called interrupt flag bit. So every device has its own interrupt flag bit, right? So it's very interesting story. That's how it works. Look here. Number one, the device has to put 1 here in this bit, right? To trigger interrupt. This is number one, okay? And then this is done automatically by the device. And then once I decide, the CPU, once the CPU decides to serve the interrupt, the CPU is gonna go to the subroutine, ISR subroutine, as I told you. You as a programmer, you must write here one instruction to clear this bit because I already served it. You got what I'm saying? Let me tell the story again. Number one, the device automatically, if the device want to trigger interrupt, the device is gonna put 1 in, is gonna set a bit. This bit is called interrupt flag bit. Okay. This, you are not gonna do it. This is by the hardware. However, your responsibility is you have to write one instruction here in the interrupt subroutine to clear it. Makes sense, right? Because when it is clear, it's done. I already served it. Once I clear it, maybe in the future, this device is gonna request trigger interrupt again. Okay, so it's gonna put 1 here. That's how it is. So every time one device is gonna put 1. So this is a common bit. Device is gonna put 1. Then in the subroutine, once you serve, you have to clear it. Is that okay? What happens if you forget to write this command? What happens? I know some people already did that before, and you may make this mistake in the project, in the capstone, in the coming lab. You may make this mistake. If I forget to do this one, what's going to happen? Yes, it's going to be continuous interrupts. What's going to happen is that, as you know, this is the main program. So this is the main program, right? So if there is interrupt, I'm gonna go to the subroutine and then I'm gonna come back. If there is another interrupt, I'm gonna go and come back. If no interrupt, I'm gonna go this way, right? If there is no interrupt, I'm gonna execute the main program. What happens if there is one here? Okay, I'm gonna microcontroller is gonna leave the main program, go execute a subroutine, and then come back. Once it comes back, it's gonna think there is another interrupt, so it's gonna go execute it again and come back. Oh, there is another interrupt. So you are not gonna execute the main program. Okay, so you can notice this one. You can notice that the task you are putting in the main program is not working. Why? Because all the time you are serving the same interrupt because you forget to clear it. Is that okay, guys? Simple. So this is what we call interrupt flag bit. So again, I already accept one bit. I call it enable bit. Enable bit. For every source, if I forget, you have to ask me, what is the enable bit? For every source, I have to tell you what is the enable bit, okay? Also, for every interrupt source, I have to tell you where is the interrupt flag bit, okay? Because you have to write a command here in the interrupt subroutine to clear it. Is that okay, guys? Any question? And again, the way you are going to clear it, very simple. It is just a register, it's a byte, and there is one bit there. It can be here, it can be here, it can be here. It depends on the source. I'm going to tell you in this register, this bit is the interrupt flag bit. You have to clear it. You got what I'm saying? Any questions? You understand how they communicate together? Okay, it's like we're communicating right now. So if you need to interrupt me, you're going to raise your hand. Once I respond to you, you have to lower your hand, right? It's the same story, right? So here's a device has to put one here, okay, and then once I serve the interrupt, I'm going to put 0 here, okay. Okay, I'm going to tell you something interesting. Sometimes, but in very rare cases, but sometimes, I wanna, as I told you, interrupt should come from a device. Interrupt should come from a device. That's how it is. The device has to put one here. What if in my program, I put one here in my program? Because this is just one bit in a register. So I can write a command to put one here. Okay, that's what we call software interrupt. So I can trigger interrupt by this way. But again, this is not very common. You may not need to do it. But just this is just a machine. They don't understand. Once there is a one here, that means there is interrupt. Okay. Once we serve an interrupt, you have to be 0. Most of the time, this one has to come from the device. Okay. But you have to write a command to clear it. Any questions? So this is the second bit. So number 1, I explained you have to use CLI. This is for all interrupt sources. Number 2, every interrupt source, I have to tell you where is the enable bit. Should be one bit in a register. We call it enable bit. This bit is used to enable or disable this source. So that's what I'm saying. It looks difficult because you have to write 5, 6, 7 instructions to program the interrupt, but it's not difficult. Why? Because what I'm going to do in source 1 is exactly the same thing what I'm going to do in source 2. You get what I'm saying? So anyway, so it's very easy in programming, in my opinion. If you just understand one, it should be very easy. Okay. Number 3, I have to tell you what is the interrupt flag bit. Okay, you don't need to do anything about this interrupt flag bit other than here in the interrupt subroutine. In the interrupt subroutine here, you can put you have to write an instruction to clear it. Okay. Any questions? Okay. Next point here. Okay. I told you guys we have different sources for interrupt, right? So for example, we have RTI, we have IRQ, we have serial communication 0, serial communication 1, and you have different sources. That's what we agreed, right? Every source should have its own subroutine, interrupt subroutine, ISR. That's true. So everyone has its own subroutine. So if the interrupt comes from RTI, I'm going to execute the subroutine of RTI. If the interrupt comes from IRQ, I'm going to execute the subroutine of IRQ, and so on. Is that okay? Now the question is, where in memory I have to put these subroutines? Where in memory? In what addresses in memory? Remember, this should have an instruction. So it should be written in memory, like any machine code. So this part should have a machine code. It should be in memory. So where in memory? Where in what addresses? Do they have like fixed addresses, fixed locations? The answer is no. They give us flexibility. The memory is yours. Do whatever you want to do in the memory. The memory is yours. You have full control. You can manage the memory as you want. The memory is yours. Is that okay? So it's up to you. You can decide wherever you want to put every subroutine. So if this is a memory, for example, I'm going to say, starting from 7,000, I am going to put this one, ISR. However, starting from 10,000, I'm going to put IRQ. It's up to you. Wherever you put it, It's okay. But that doesn't make sense, or something is missing here, because if how I am microcontroller, okay? How I can know if I receive interrupt from RTI, how I can know where is the beginning address? Because you put it somewhere. You need to tell me. You understand what I'm saying? So number one, you can put the subroutine anywhere. Okay? But just tell me that RTI is gonna start from 7,000. So that every time I receive interrupt from RTI, I'm gonna go to 7,000. You have to tell me IRQ should start from 10,000, for example, so that every time I get interrupt from IRQ, I'm gonna go to the beginning address of 10,000. Okay, but what about the last address? You just give me the beginning address? Yes, I don't need the last address. Just give me the beginning address. Why? Because the last instruction in any subroutine should be return a subroutine RTI. You remember, as I'm gonna elaborate later, but remember when you created the normal subroutines, it has to end this with RTS. Do you remember RTS? Return subroutine, right? Now we have a similar one to RTS, but it's called RTI. It's not RTI. Is that okay? So it is enough to give me the beginning address, right? Why? Because I'm gonna execute an instruction until I find RTI. Is that okay, guys? Okay, so number one, you can put the subroutine anywhere, which is very good. They give us flexibility. You can put the subroutine anywhere, but simply you have to tell where is the beginning address. Is that okay? How I can tell where is the beginning address? How? I'm gonna tell you how. So what they did is, for every interrupt source, this is the memory. This is the memory. For every interrupt source, I'm gonna reserve. We're gonna reserve 2 bytes. Okay, in the memory. So in the memory, for every source, I'm gonna reserve 2 bytes. Why? To write the beginning address here. You got what I'm saying? So for example, IRQ interrupt, you can put it anywhere. However, there is a certain addresses you have to give me. You have to give me the beginning address and put it here. And as a CPU, as a CPU, I'm gonna go to this location. I'm gonna see what is the number there, and this is the beginning address. You got what I'm saying? So here, we are gonna define or reserve 2 locations, okay, for each interrupt source. You have to write the beginning address of your subroutine in these 2 locations to tell the CPU where is the beginning address. Is that okay? So number one, so where are these 2 locations? I'm gonna tell you where. Look here, guys. So here, this is for every interrupt source, you can see a number here. This number is called vector address. So the vector address, this is where you have to put the beginning address there for this source. Okay, that's why you can see it is incremented or decremented by 2. By 2. You get what I'm saying? For example, here, for example, in RTI, guys, in RTI, you can put the subroutine anywhere. However, you have to put the beginning address in this one and next one. So it's going to be 0 and 1. You can see everyone is incremented by 2 and so on. This one, this is the vector address. So the vector address, this is the reserved location where you can put the beginning address there. Is that okay? Also, this is something you have to do in your program. So in your program, you have to put the beginning address here. I give you very good example here. For example, look here, guys. I'm gonna talk about IRQ. This is an interrupt source. So what is the vector address for IRQ? Okay, let me see the table. You told us here, if you go to the table, this table, you can see here, guys, IRQ. So this is the vector address. That's true. So that means, as you see here, in this location and next one, I have to put the beginning address. For example, if the IRQ interrupt subroutine starts from this location, 4103, so you have to, in the beginning of your program, you have to do initialization. A part of the initialization is you have to put the beginning address, you have to put it in these 2 locations. Okay, guys? Very simple. So what you have to do in one interrupt source, you have to do it in the other interrupt source. The only difference is the number, what number you have to use. That's it. That's why I'm telling you it's easy. Once you learn one, all of them are the same. Okay? So what I have to do here to initialize IRQ, same thing I have to do here. The only difference For IRQ, I have to use this one. For RTI, I have to use this one. Okay, guys? So how can we do that? This is the way you can do it. So in the beginning of your program, in C, you don't need to do that in C. It is automatically done. I'm going to tell you how it's automatically done, but in assembly you have to do it. Okay. So the way you have to do it, guys, you have to define a subroutine in your program. You can call it any name. For example, IRQ interrupt subroutine or any name. It doesn't matter. So this is the interrupt subroutine for IRQ. Okay. And then you have to use this. You have to use this instruction at the beginning of your program, org. You remember org in the beginning. So for example, here, guys, I'm going to say, and then the beginning, the address, the name of the subroutine, I'm going to put it here. So what's going to happen here, I'm going to say org ff2, right? And then I'm going to say this dc.word, and then I'm going to put this one, because this is the name of the subroutine, and this is the same name. This name is going to be replaced by the physical address. Right? So I'm saying, instead of bothering yourself, and to go and see what is the beginning address, you just use a name, English name, right? So same thing here. The compiler is going to replace this name with the address. For example, specifically in this case, as you see here, guys, this is the IRQ interrupt subroutine. Okay, so it started from 4103. Okay, I don't need to bother myself and see what is the beginnings. Okay, all what I'm gonna do, I'm gonna just write the name of the subroutine here. And as I explained before, once you write the name, interrupt subroutine is gonna replace this one by 4103. Is that okay? 4103. So you can write this one here in this location. Okay. By the way, I tried to use move before. I tried to use move instruction. All what I want to do, guys, I just want to write a word in this location. Okay. I tried to use move, but it didn't work. That's because I guess my guess is these addresses are in the flash area, and the way you will read or write a flash memory is different from the way you will read or write a RAM. RAM, it's easy, you just write byte, but in flash, for flash is somehow more complicated. You have to read a block, complete block, and so on. It's somehow complicated. That's why I put it using org this way, so that you remember when you run your program, you see a message burning flash. Yeah, so this is gonna happen in the very beginning. You are gonna burn the flash. Anyway, so what I'm saying, guys, here is let me tell you the conclusion. The conclusion, one of the things you have to do to program interrupt is you have, so now your program, what we did before was, look here, guys. What we did before, we used to have two orgs, org 1000, and then you put your data here, arrays, variables here, and then we have here also org 4000, and then your program, your code is here, right? So that's what we did so far. Now we have more orgs. Okay, so for example, I can put it here or I can put here, it doesn't matter. Okay, for example, here I can put one org here for RTI. I can put another org for, so everyone is going to have like something like that. The only difference is every interrupter should have one like this one. You can put all of them here, it doesn't matter, or you can put all of them here before, so before this org or after it doesn't matter. Okay, so but for every interrupter, so you're going to have one like this one. The only difference is you may change this number by changing the interrupt source. You have a different number, and you can get the numbers here from this table. This is one difference. The other difference is the subroutine, for sure they have to have different names. Okay, again, this name, this English name, I call it IRQ interrupt subroutine because this is what this subroutine is about. But you can call it anything else. It's just English name, right? So here, every interrupt subroutine should have a different name, right? Just to put the name here of the interrupt subroutine and put the interrupt vector here. Any questions? Okay. Before I move forward, look here, guys, what I'm saying. To program interrupt, number one, you have to do CLI to enable all interrupts. Number two, you have to write an instruction to enable the local interrupt bit for the interrupts you are using. I don't need to enable all of them. In my program, I'm using only RTI. So just, yeah, you have to take care only for RTI, right? So anyway, so this is number 2. Number 3, inside the interrupt subroutine itself, you have to write an instruction to clear the flag bit. Otherwise, you are going to have continuous interrupt. Your program is going to be frozen all the time. All the time is going to go execute, interrupt, come back. Yeah, there's another interrupt. Go execute, come back. There's another interrupt. You got what I'm saying? So anyway, this is number 3. Number 4, you have to initialize the interrupt vector or the vector addresses. Okay. So here we interrupt vector. This is 4103, which this is the beginning address of the interrupt subroutine. So you have to store it in a predefined location, fixed location, predefined location. We call it vector address. Also, you have to do this one. Okay. So yeah, so here you can see the vector address for each interrupt source. Okay, guys, any questions? Okay. The last thing you have to do, the last thing you don't need to do it, but I'm gonna explain it. The last thing I wanted to explain here, guys, we call it interrupt priority. Interrupt priority. What this means? I'm gonna tell you what this means. Look here, guys, very simple. What happens is, look here, guys. For example, I have device 1 is triggering interrupt, and also device 2 is triggering interrupt. Device number 3 also is triggering interrupt. Okay, so microcontroller, I'm gonna look, for example, 3 people, you can raise your hand, raise your hand, and I need 3 people to raise their hands. Yeah, 1, 2, 3. Yeah, keep it raised. Yeah, so I have 3 now. So can I serve all of you at the same time? No, I have to select one of you, right? Then after I finish, I have to go to the second one. Then after finish, so how I select? So there should be some priority. Okay. For example, I'm gonna put a rule. The rule is who raised first, I'm gonna serve first. For example, so this guy raised his hand first, so I'm gonna serve this guy first, and then after I'm done, then I have to decide, should I go for you or serve you or serve this other guy? So that's what we call priority. Okay. So in this case, how can we determine the priority? How can we determine it? Okay, which one I have to, just in case more than one interrupted triggered at the same time, right? So the way we do it here is, number 1, we have fixed priority. Fixed. What do you mean by fixed priority? I mean, look here, guys. Who comes first in the table here? Who comes first in the table has higher priority. Let me give you example. For example, IRQ come here. Timer channel 7 come here. So if I receive 2 interrupts, one from here and one from here, which one I should serve first? For sure, IRQ, because IRQ has higher priority. Who comes here in the table first has higher, for sure. Reset has the highest priority. Okay, guys, any questions? Okay, so once, okay, for example, this is how it works. For example, now I have IRQ and then I have timer channel 7, and then I decided I'm gonna go for IRQ, and then when I execute the subroutine of IRQ, channel 3 triggered interrupt. So after I finish, I'm gonna come and look again. Now I have 3 and 7. I'm not gonna say 7 triggered before 3. No, I don't care. Every time I'm gonna decide, right? So now I'm gonna decide 3 and 7. No, 7 has more, so I'm gonna go for 7, and so on. You got what I'm saying? So anyway, so the way we do it here again. By the way, maybe when you study a different microcontroller, maybe they do it in a little bit different way. Okay. However, there should be some rule. So should be some rule to determine which for priority. Okay. So anyway, although it is fixed, we have some capability to do something here. Okay. For example, here this microcontroller allows you to select one source and put it on the top of everybody. Only one. Okay, guys. So number 1, the priority is fixed. That's totally fine. However, you can select one for some reason. I want to select this one. I'm gonna put it on the top. How can you do that? I'm gonna tell you how can you do that. All what you have to do, guys, is Yeah. So as you see here, guys, I have to write an instruction like this one. I have to write a number in a register. This register is called H high priority, or HPRIO, right? So you have to write a number here, okay? If I do that, so every interrupt source has a different number. If I do that, so this is allowed for only one source. You can select one source, you can put it on top of everyone, okay? So how can you come up with this number here? Okay, I told you every source should have only one number. So it's very easy. This number is, look here, guys. This is the least significant byte of the interrupt vector. Okay, that means if I, for some reason, if I want to pick up this guy, and I put it on top of everybody, so I have to put DE. I have to put DE in this register. We're not gonna do this in this course anyway, so you can just use the same priority. So we're not gonna do it. You don't need to worry about it, but I just want to explain it because you may need it in capstone or something else. You may need it. You got what I'm saying? So, but you understand what I'm saying? So about the idea of priority, which one you want to execute first. So let me ask you a question. Why I should care? Why I should care about it? Who's gonna be executed first? Should I care? Can anyone make a guess? Should I care? For example, as long as you are going to serve everybody. So why I care? This one should have more priority. So if you have interrupts from 3 sources, so I have to do this one first. For example, should I care? In some cases, for sure in some programs it doesn't matter. For sure in some programs, but why in some cases? Can you make a guess? Why sometimes I need this one to be executed first? No, this is what means the input of one is important for others, the output. But here's you are very close. You are somehow close. But let me give you, for example, if you have something like fast data acquisition. Okay. For example, you're receiving data very quickly. And if you don't respond to this interrupt quickly and go and capture this value, maybe another value is gonna come. Okay. So in this case, so for example, in serial I'm just saying example, serial communication, I wanna give more. So it depends on what this device is doing. So for example, if this device is doing flashing, I don't care if the flashing is gonna be delayed. If you keep it on for 10 microsecond more, or I make it second, but it's going to be second plus 10 microsecond. I don't care. This is not something like critical. It's not critical. However, if you have interrupt, for example, coming from something very dangerous like alarm, like for example, fire alarm, something like that. No, this one should have more priorities than the other ones because it's something very dangerous. Okay. Also, if you have, as I told you, for example, in something like serial communication, for example, in serial communication, you have some data came here. So if you don't take this data in quickly, maybe another data is gonna come. Okay, so you wanna take this one first before the other one comes. Okay, maybe I'm saying I don't think you are gonna need it in this course, but for sure in some application you may need something like that. One more thing, very important, you should keep in mind. Listen to me. Look here, guys. For example, in some application, I wanna track how many interrupts happened. Okay, as you will see later in this course. Okay, for example, if I want to measure the motor, the speed, if I want to measure the speed of a motor, so as you will see later in this course, we're going to generate signals like this ones. So I want to count how many signals, and then I'm going to do some equation. I put it in equation to calculate the speed, something like that. Okay, listen to me here. Look here. Look, for example, guys. So if this device is gonna put one here to trigger interrupt, is that okay? Normally, I should execute the subroutine and then I have to go put 0 here. Normally, right? And then What if interrupts are coming very fast? What if faster than the microcontroller, for example? Or what if I was busy serving another one? Look what's gonna happen. So this one is gonna trigger interrupt, is gonna put one here, okay? And then another event came. Another event came before I clear it, right? So this one is gonna put one again. So now 2 events, and I'm gonna count them like 1 because events are coming very fast. You got it? You got what I'm saying? So I have 1 event. This event just put 1 here, okay? And then before, and I was busy serving others. For example, I was busy serving others. And the second event came very fast. So it's gonna just put 1 here. So I'm gonna make one. I'm gonna execute the subroutine 1 time, right? For 2 events. I will not even know that there are 2 events. You got what I'm saying? So I'm gonna lose 1 event. This is if everything is too fast. Maybe in a scenario like this, maybe in a case like this, this device I have to give more priority than this device because this is very sensitive to the time. Okay, guys. Anyway, again, I don't want to spend more time on this. What I'm saying is a conclusion. What I want to say. Number 1, for the purpose of this course, I don't think you are gonna need something like that, like the priority here. However, maybe you are gonna need something like that in like big, like capstone or something like that. So you should keep in mind that you should have a capability to give priority to one interrupt more than others, especially if this interrupt is very sensitive. You have to serve it fast before others. Otherwise, your program is not going to work correctly. You got what I'm saying? Anyway, so this is up to you. Now I wanna tell you the complete story, how everything works. Before I almost finished here. I almost finished this part, but I just want to put like a complete story. What I did so far, I explained just pieces. Now I want to put all the pieces together to explain the whole story. So let's see how it works. This is what we call a complete interrupt service cycle. Okay. So number 1, the cycle should start from the interrupt flag bit. This is the beginning. Makes sense, right? So the interrupt cycle should start from here, as I told you. The device, this is the beginning. So the device has to put 1 here. Is that okay? This is step number 1. The cycle will start right now. Okay, and then what's gonna happen after this one put 1 here? I'm gonna tell you what happens. Okay. Number 2. If the interrupt is disabled, now I have to check the interrupt of this source is enabled or disabled. If it's disabled, okay, so I'm not gonna do anything, just ignore it. You got what I'm saying? Just to complete. So just to do the main program, serve other interrupts. It's done. I finished. Okay. So now I'm gonna check how I can know if it is enabled or not. As I told you, I have to check the I bit. Also, I have to check the local enable bit for every source. If it is disabled, I am done. If this source is enabled, so I'm gonna move to the next step. What is the next step? Next step, I have to see if this is the only interrupt I have, or this interrupt has the highest priority. In this case, I'm gonna continue. Otherwise, I'm not gonna serve it. You got what I'm saying? So again, guys, number 1, the interrupt cycle starts by the device has to set the interrupt flag bit. This is number 1. Okay. Number 2, if it is enabled, if this interrupt is enabled, and this interrupt is the only interrupt we have, or this is the interrupt that has the highest priority, that means, okay, so I'm gonna start serving the interrupt. So what should I do to serve starting from here? Okay, guys. So now I decide to serve the interrupt. Okay. So to serve the interrupt, what should happen? Number one. All the CPU automatically, the CPU is gonna push all the registers except stack pointer. Okay, it's gonna push it to the stack automatically. You don't need to write to push instruction. This is done automatically, right? So in the beginning of the cycle, the CPU is gonna push all the registers, is gonna push them, all of them to the stack, 9 bytes. Push them all to all the stack. Is that okay? Okay, guys. Why you are doing that? You remember when I told you in any subroutine, it's a good programming habit to put push in the beginning and a number of push instructions in the beginning and a number of pull instructions at the end, as I told you. Why? Because this is the main program. This is the main program. I'm going to leave the main program, go execute a subroutine and go back. Maybe here in the subroutine, you are going to use register A, register B, register Y, whatever. Okay? So I don't want to mess up. I don't want you to mess up with the main program, right? So if you change a register A here, it's not going to change the main program because I'm going to push in the beginning and then I'm going to pull it back. So that when interrupt happen, you're not going to damage the main program. You're not going to change the values of the register. Okay? That means inside the interrupt subroutine, you can so automatically all the registers are pushed, 9 bytes in total. Okay? So automatically inside in the interrupt subroutine, you can use any register. You don't worry that this register you are going to change important value in register A or register Y or X. You don't need to worry about that, right? Because all these values are going to store in the stack, and then at the end I'm going to get them back. So you can use all the register without using push or pull. You don't need to use push or pull. Okay. So this is automatically done. This is so when the CPU decide to serve an interrupt, automatically the CPU is going to push all the register to the stack. Okay, this is number one. Number two, the CPU prevents what we call nested interrupts. What do you mean by nested interrupts? I'm going to tell you what I mean by nested interrupt. Look here, guys. Okay, so now I told you here I have the main program, guys. This is the main program, including subroutines. All of that I'm going to call it the main program. I got interrupt from IRQ. So I'm going to go to IRQ and then I'm going to come back. Is that okay, guys? What happens if when I execute IRQ, interrupt happens from RTI? Should I leave this one and go here and come back? Should I do? It's like when a subroutine is call another subroutine, right? It's okay for subroutines, but for interrupts, no. Nested interrupts are not allowed. Nested interrupt. So that means if I have interrupt from IRQ, okay, so I'm not gonna respond to any other items, even if this interrupt has more higher priority. You know what I'm saying? So what's gonna happen? I'm gonna disable. The CPU is gonna disable all interrupts. Okay. Well, at the very beginning here, once I finish IRQ and I come back, now I'm gonna go execute RTI. So nested interrupts are not allowed, regardless of the priority. Regardless, that's exactly what happens here. So what happens here? Once I decide to serve one interrupt, so the CPU is gonna prevent further. How the CPU can do that? Practically, how can you do that? By disabling all interrupts. Because I'm saying that automatically, again, you don't need to do anything. This is done automatically. Once the CPU decide, okay, so now I decided to select IRQ, and now I want to serve IRQ. So automatically it's gonna set I to disable all interrupts, because nested interrupts are not enabled. You know what I'm saying? And then once I finish IRQ, I'm gonna go again to enable all interrupts again. Okay. So anyway, now what is the next step here? The next step, I have to get the beginning address of this interrupt subroutine. I have to get the beginning address and I have to put it in PC. How I can get the beginning address? Very easy. That's what I told you here. So every interrupt subroutine has a location here, 2 bytes. So the CPU, for example, if I have interrupt from RTI, the CPU is gonna go to this location. It's gonna get the address there, and put it in PC. Similar to jump. You remember when we did jump and put the address in PC, same thing. But again, all of that done automatically, okay? So in order to jump from the main program to jump to the subroutine, the way I have to do it, PC. So I have to get the beginning address, put it in PC. Yes. Okay. And then, so now once I do this, so now I'm gonna go to the subroutine to execute the subroutine. Okay. So inside the subroutine here, This is not automatically. This is your responsibility. Your responsibility is to write. You need to write an instruction to cancel the interrupt request. Okay, so that's what I told you. You have to write an instruction here to clear this bit. Okay, you have to do it. You have to do it, guys, for all interrupt sources. So for all interrupt sources, you have to write an instruction here to cancel the request, because I already served the request. So I have to write an instruction to put 0. So for all sources except one source, IRQ. So the only exception is IRQ. In case of IRQ, this bit is automatically cleared. You don't need to worry about it, right? So, but for all other sources, you have to write a command to clear the interrupt flag bit, except one, IRQ. Okay. Anyway, so what else? Then now, so now I'm gonna move here. I'm gonna execute all the instructions here until I hit RTI, until I find RTI. Okay. So here you can inside any subroutine, you have to use all registers without fear of interfering with the main program. There is no interfering with the main program. You get what I'm saying? So if I can change register A or B or X or Y, and this is not going to have impact on the main program because the initial values are going to return back. Okay. You don't need to push and pull as usually we do. You don't need. Okay. And then, but for memory locations, for example, if I want to use a certain memory location and the main program is going to use the same memory location. No, if you want to do something like that, you have to push and pull. So you have to do it by yourself. The hardware is going to only keep the initial values of registers, only registers. Okay. And then, very important, look here, guys, registers cannot be used to return values from interrupt subroutines. We're gonna need this one later. What this means? Okay. What if I want to return something from this subroutine? For example, I want to count how many interrupts. Can I do this way? That's what we're gonna. I want to count the number of interrupts. For example, so here, this is IRQ. I'm gonna say increment A. Okay, yeah, it should work. So every time there is an interrupt, I'm going to increment A. Every time there is an interrupt, I'm going to increment A, right? No, it's not going to work. Why? Because automatically the initial value for A is going to be saved and they're going to return it back. So whatever value you want to return from the subroutine, you cannot use registers to return any value from the subroutines. Okay, because all the registers automatically are going to get the initial values back. So if you want to return something from the subroutine, like you did some measurement, I measured the speed, I measured whatever, I counted something, I want to return a value. It has to be a memory location. It cannot be registered because all registers should get the initial values back. And then finally, by the end of the subroutine, guys, you have to write RTI. What RTI should do? RTI, okay, very simple. RTI is gonna pull 8 bytes from memory, put them in the register. So the opposite of what we did here. So here we push 8 bytes. RTI is gonna pull 8, including the return address. What is PC here? Including the return address to return it back. Okay, guys, and that's it. Okay, so I'm gonna say this one again. Again, it's not, you will see right now, it's very simple, but let me say it again, and then I make here a summary on programming. What should you do in programming? And again, as I told you, it's easy. Once you learn how to do it one time, all of them are the same. So I make a summary here, but let me go through it again. Okay, guys, this is a complete cycle, okay, for one interrupt. Number one, the cycle should start when there is an event. And when there is an event, so the interrupt flag bit should be 1 from the device. As I told you, this is similar when you raise your hand, right? It's the same thing. You trigger interrupt. So the device has to put 1 here in the interrupt flag bit. This is the beginning. Once this happens, the CPU number 1 has to check. I'm going to serve this interrupt if these 2 conditions are true. The CPU should execute it, should serve you. I'm gonna serve you if these two conditions are true. Number one, I bit is enabled and local enabled bit are enabled. This is number one. Number two, you are the only interrupt I have, or you have the highest priority. Okay, if these two are true, I'm gonna serve you. When I serve you, I'm gonna do that. So serving is gonna start here. Serving. Here I have to determine should I serve you or not. Should I serve you or not? Okay. So when I serve you, automatically you don't need to do anything. Automatically, the CPU is gonna push all the register 8 bytes automatically, right? And then it's gonna disable interrupts automatically because nested interrupts are not enabled. Then it's gonna get the beginning address from the location, from the predefined location here. So you have to put it here, okay? So you have to, it's gonna get the beginning address, it's gonna put it in PC. So that to jump, because of this step number 6, I'm gonna jump from the main program to the interrupt subroutine, because the beginning address is I'm gonna put it in PC, right? And then after that, okay, and then I'm gonna go to the subroutine after you put the beginning address in PC. So I'm gonna go to the beginning, I'm gonna go to the subroutine. I'm gonna execute the subroutine here. You have to make sure you write one instruction to cancel the interrupt request, the interrupt flag bit, okay, for all the sources except one, IRQ. Don't need to do that for IRQ, it's automatically done for IRQ. But for everyone else, you have to write a command to do that. Okay. Number 3, you should, after that, you just here you can use all registers. All registers, you don't need to save the values for register. However, if you are gonna use the memory location and the same memory location is used in the main program for some reason, so you have to push and pull this value. Otherwise, you are gonna interfere with the main program. Okay. Finally, you have to write RTI at the very end. Is that okay, guys? Any question? Let me ask you a question very quickly. So why we need a new why I need RTI? Why I don't use RTS? How they are same? What is the similarity and the difference? Okay, there is the main difference between them. You remember, RTS is gonna pull 2 bytes from the stack and put them in PC, return address, if you remember. But RTI is gonna pull 9 bytes, as you see here, 9. That's why they are different. That's why we need a different instruction. RTS is not gonna do what we need here, right? So RTI, but they are very close. But the only difference is RTS is gonna pull only 2 bytes, return address, put it in PC as I explained before. But RTI is gonna pull 9 bytes. Anyway, so now let me tell you. Yes, maybe I spent too much time, explained everything in details. Now give me the conclusion. This is the conclusion here. The conclusion, guys, for any interrupt, I have to do these tasks. Number 1, I have to initialize the interrupt vector. This is number 1. How can you do that? As you go back, so you have to write something like that. I'm gonna give you for sure example, but you have to do this one. Okay, you have to put the beginning address in a certain location. Okay, and then all the locations as you see are here. Okay, this is number 1. Number 2, you have to enable interrupts, the global I using CLI. Also, you have to enable the local interrupt bit, the local bit. Okay, so that's something you have to do. Number 3, or the next point here, you have to do configuration. This configuration may be different from one source to another. For example, let me give you example. In case of timer, I have to tell the timer, for example, interrupt me every 40 milliseconds, or every 20 milliseconds, or every 10 milliseconds. So I have to write a command to set the timer. Right? That's what I mean configuration in this case. However, in another case, so this is the only ones that can be different from one interrupt to another. Okay. For example, in another case, so you need to set the time out in case of timer. But in case of IRQ, as I'm gonna explain right now, guys, IRQ is 1 pin. Every time there is a falling edge here, or there is 0, 0, you can trigger interrupt. This one or that one. It's up to you. So I'm here, I'm gonna connect like a sensor. I'm gonna connect a sensor, a circuit, whatever. Okay. So now I'm gonna give you a choice. It's up to you. What do you want? You wanna trigger interrupt when falling edge come here, or you wanna trigger interrupt when it is 0, level 0. You have to write a command to select which one you want. This is what we call configuration. When I talk about timer, here, also it has a pin, as I'm gonna explain later. This pin, you can trigger interrupt if it is falling edge, or if it is rising edge, okay, or both, if it is falling, rising and falling. So if there is rising, you trigger interrupt. Falling, also you're gonna trigger interrupt. Choice. So you have choices here. It depends on what you want to do. You can select. So in case of timer, you can trigger interrupt. In this case, it depends on your application. What do you want to do? So in some application, I need this one. Some application I need this one. Some application I need both to trigger interrupt in both. Okay. So again, how I can select? You have to write a command. That's what I say configuration. So configuration here is going to be different from one source to another. But everything else, like this one, everything else will be the same. Okay. So now, what else you have here? Also, inside the interrupt subroutine, you have to put RTI at the very end. Also, you have to clear the interrupt flag bit for all sources except IRQ. That's it. No, so let me tell you the summary again. The summary is when you program any interrupt, guys, you have to do this one. This is must, number one. Number two, you have to enable interrupts. Once you enable interrupts, okay, so now at any time interrupt can happen. So once there is interrupt, I'm gonna go and come back. Okay. So anyway, so you need to enable interrupts. Inside the interrupt subroutine, you have to write this command to clear the interrupt flag bit, and you have to put RTI at the end. On top of that, you have to do configuration. That's it. And this configuration is going to be different from one source to another. Any question, guys? Now I'm going to give you details now. So details here, what I mean, for example, I'm going to take cases. So for every case, like IRQ or RTI, for every case, I'm going to explain to you how can you do this one, how can you do this one, which is not difficult. As I told you, all of them are the same, just change numbers. Okay. Anyway, as you will see. So here in this chapter, guys, I'm going to explain I'm going to add one more, but for now, at least I'm going to focus on 2 interrupt sources. One is called IRQ. The other one is called RTI. Tell us, what is the difference? Very simple. The difference is RTI is a timer, right? So it's like a timer. You have a timer here. This timer should generate periodic interrupts. You can just set the time. All what you have to do, I set the time. I'm gonna ask the timer, please timer, interrupt me every 10 milliseconds. Okay. So how I can use it? Very simple. If you want to do something periodically, you can use timer to do that. Okay. For example, I want to do flashing. So every 1 second, I want to flip LED. That's it. That's how can you do flash. Or every half second. It depends. So every half second, I want to flip LED. So I'm going to ask the timer, please timer, interrupt me every half a second. And then in the interrupt subroutine, so now if I do this way, so now I have interrupt subroutine. This subroutine is going to be executed every half a second. So you have to write it an instruction to flip LED. That's it. Guys, it's very simple, much simpler than what I did before when I did flashing. You know why? Because most of the work, you are not going to write a code to do it. Most of the work done by the hardware, by the timer. Okay, so you are not going to write a code to count for 1 second. The timer will do that. You know what I'm saying? That's why you will find when you use interrupts, you are going to love interrupts because it's going to make programming easier. Because most of the work, you are not going to do most of the work. Most of the work is going to be done by the timer. You get what I'm saying? So if I want to do flashing, think about it. See how we did flashing LED before. Okay, now I'm going to do flashing LED. Okay, using just one instruction. I'm going to write in the interrupt subroutine. So in the interrupt subroutine, I'm going to say flip LED. That's it. If you execute this subroutine every half a second, you can make a flashing every half a second. And you don't need, that's all. So using only one instruction, you just put it inside. I just want you to understand, because most of the work already done by external circuit somehow. Anyway, so this is for RTI. RTI is going to be used if you want to make periodic interrupts. Okay. IRQ is different. IRQ, guys, we have here external pin. This pin is called IRQ. So this pin should be connected by a sensor or connected to whatever. So every time there is a falling edge or zero level, you want to trigger interrupt. So the falling edge can come from a sensor, like you have a fire alarm, okay, or whatever, or you have a sensor like train sensor. It's going to sense if there is a train or not, or whatever. So every time there is a falling edge here, you trigger interrupt, you execute a subroutine. Is that okay? And then you can write there whatever you want to write, as you will see right now. Okay, now I'm going to focus on RTI. Again, I'm going to use this slide. I'm going to show how can you do this one. Everything should be easy. So let's start with IRQ. Okay. So here, IRQ. I told you IRQ, it has external pin, right? Where is this external pin? This one here. PE1. You can use. Can you see this one? This pin here. So if I have the board here, the second one here. Second one. This is IRQ. Okay, it's the second one here. I can connect it to, as you see. So this is the pin, external pin. I can connect it to a sensor or whatever. Every time there is a falling edge, I want to trigger. I'm gonna trigger interrupt. Again, trigger interrupt means I'm gonna execute a subroutine. So every time there is an event, like a falling edge coming from a sensor, I'm gonna execute a subroutine. Then you can write whatever you want to write in the subroutine. Okay, depends on what you want to do, for sure. Depends on the application, but it should work this way. Okay, so IRQ, guys, allows you to connect externally here. You can take this pin, you can connect it to sensor or whatever, and allows you to select. Do you want to trigger interrupt when there is a falling edge or when there is level zero? It's up to you. Okay. So now, how I can program IRQ? Okay, same thing as explained now, but I'm going to give you more details. Number one, you have, as I told you guys, you have to initialize the interrupt vector. How you initialize the interrupt vector? For sure, again, this can be any name, guys. This is the name of the subroutine. You can call it any name, okay? But for sure, it makes more sense. If you have a variable to measure speed, it makes more sense to call it speed, not temperature, right? But that doesn't mean if I call it temperature, microcontroller is going to be confused and going to think this is temperature, not speed. No, they don't understand. This is just number. This number, sorry, this is just names. These names for us. So anyway, so just a name. So it just makes sense to us to call it IRQ interrupt subroutine. Anyway, so this is a subroutine. This is the name of the subroutine. So IRQ ISR colon, and then you can write here and then end it with RTI. Okay, guys. So CodeWriter is going to replace this one and put the beginning of this. So number one, in your program, you have to write this one, guys, to initialize or to initialize the interrupt vector. So, and always for IRQ, you have to use this number. How you came up with this number? Here for name, you can use any name. It doesn't matter. You can use any name. However, for this number, it is a must to use this number, right? Because CPU already, this is a predefined location by CPU. Okay. So how can you get this number? As I told you, it's here. So if you come here, that means when I explain RTI, I'm gonna repeat what I explained right now, but instead of using this one, I'm gonna ask you to use this one. That's it. Okay. This number one. Number two, how can you do configuration? Number one, what kind of configuration you have here? Because configuration is going to be different from one device to another. What kind? We have only one type of configuration here. Okay. You want to trigger interrupt when there is a falling, rising or zero level. Okay. That's what I mean by configuration. Is that okay? So you have to, the choice. It's up to you. It depends on how the external circuit is connected. It depends on what you want to do. You wanna trigger interrupt when there is on this pin there is 0 volt, or you want to trigger when there is falling edge. Okay. So you have the choice. So how can I select? Very simple. That's what I'm saying about configuration. Very simple. As you will see right now, Very simple. You have a register. This register has 1 bit. Oh, because I have 2 choices. 2 choices, I need only 1 bit for 2 choices. Okay. So if I put 0, I'm going to get one of them. If I put 1, I'm going to get the second one. Very simple. Number 1, what is the name of this register? This is the name of the register. Okay. This register has a number, has address, right? This is similar to GDRA. This is similar to port B. They have addresses. You have to use every instruction I taught before for memory locations. However, similar to what I did with GDRB, port B, you don't need to know the number. Just use the English name. You got what I'm saying? Similar to what we did before. So again, we have this register as you see here, guys. In this register, if you look here, very simple. We have 1 bit here, guys. This bit is called, this one, bit number 7, as you see here, bit number 7. And bit number 7, if you put 1, that means you wanna trigger interrupts at falling edges. Okay, at falling edge. But if you put 0, you trigger interrupt when it is low level. You get what I'm saying? 1 bit, very simple. Also, this is everything about configuration. That's it. Every source may have different configuration. Okay, just one minute. I'm almost done. So number 2, the last thing you have to do here, enable. How can you enable? I told you for every source there is 1 bit for enable or disable. I have to tell you where it is. Okay. Luckily, in case of IRQ, the enable bit in the same register. Sometimes it's on a different register. It doesn't matter, right? So this is bit number 6 here, as you see here. So bit number 6 here, guys. If you put 1, that means you enable IRQ interrupts. If you put 0, that means you disable IRQ interrupts. Okay. That means if you put, look here, guys. So here, if I want to enable interrupts, I have to put 1 here. Okay. And then if you want to respond to low level, so you have to put 0 here. Okay. This is going to make number 40. So all what you have to do, you have to write number 40 in this one, this instruction. So you have to write here 40. That's it. That's it. Now, if you wanna respond to the falling edge, so it has to be 11000, which C0. So you have to put here C0. Okay. Very easy. So here, this one is 1 if you want to enable it. So this one can be 0 or can be 1. In case of 0, you have to put 40. In case of 1, you have to put C0. At any time, if you want to disable IRQ interrupts, here, just put 0 in this bit. You are going to disable. Okay, that's it. So that's all what we have. To clear the interrupt flag bit, as I told you, this is done automatically, but this is the only exception. The other sources, you have to write something. That's it. Very simple. So I'm going to continue next time, but that's all. So just quickly, so all what you have to do, guys, this is number 1, very easy. For configuration and the enable, it's just 1 instruction. So 1 instruction to do these 2 together, this one. That's it. Once you do that, ready to go. Okay, IRQ can work at any time. If you wanna stop IRQ, just you have a bit here, just put 0. If you wanna return it again, if you wanna resume it, just put 1. Okay, very easy. Okay, see you next time. Yeah, sure.
I emailed you about the faculty advising.
Yes.
Would you prefer if I wore a mask?
Yeah.
The thing about me right now wearing a mask is that I'm not 100% certain on what I want to do, but I am ready to start.
You are computer engineering student?
Yes.
Yes, great. So yeah, so you want me to help you, for example, if you need some advice about your future?
Yes.
So you are genuine or?
That's kind of a complicated question.
So when you are going to graduate, in 1 year or so?
About a year and a half.
A year and a half. Okay. So what's your future plan? You want to go for do some work in industry? You want to go for grad studies? Or?
I'm still looking into all that, honestly.
Yeah.
I've been enjoying programming and working with physical
Yes.
hardware components.
Okay, great.
Quite a bit. But
Have you
that's
done
all I
any-
really know.
Have you done any internship before?
Not yet.
Not
I'm
yet.
still looking.
So I think it is worth to think about in the summer to do some internship related to what you like. You told me you like doing like some hardware stuff, so you can.
Oh, yes, my favorite course from last semester, for example, was digital systems, even though I kind of struggled in it. But
Oh, okay.
for sure, I don't know what it is. I like that
That's
a lot.
man, that makes sense.
Yeah.
It's okay. This happens. So maybe when you take more classes, you will you can make like you can make your decision. You can make your mind. When you take more classes, you will see. Now you see my course. You're gonna see other classes. Now you can think, yeah, I love this area, or I want. But my advice to you, try to, for example, try in the summer, either internship, okay, in industry, okay, or there is something we call research for undergrad. I'm not sure if you're familiar with this one. So,
I'm not.
no, yeah. So there is during the summer, some schools we have. I have one by myself, Dr. Patisharia. You know Dr. Indranil Patisharia. Indranil, you know him?
Not.
You didn't take any classes with him? Okay. So at least in our department, we have two what we call REU, research for undergrad site. You can search, you can search for this one. You will find what happens here is, REU sites. It's nationwide, everywhere. So it's coming from UNICEF. UNICEF is a federal agency. Look what I'm saying. So in our department, we have two sites, One under my I'm the PI. The other one is Dr. Indranil. For me, it is a focus on cybersecurity, but for the other one, the focus is on like battery or energy, something like that. Power. It's more about it. So you can search at least for it. So again, this one can give you experience regarding research. The reason I'm mentioning it is because they told me you didn't decide yet. Okay, so what I'm saying to make a correct decision, my advice to you, just to try to get some internship in industry, because you don't know what's industry. You don't know, you may like it, you may not. But if same thing for research, you may like it or not. So what I'm saying, there are two different types of internship. You can go to industry, and then you can get the feeling, or you can see if you like it or not. Or you can go. This one is 10 weeks during the summer. 10 weeks. Okay, during the summer we pay 600 for a week, for each week. For each week, we pay stipend to the student, 600. On top of that, we pay some money for meals. We pay for transportation.
I think I have a friend in chemical engineering who did something in
and housing.
Exactly like this.
Yeah. So it's good. I think total you can get 6,000. Okay. Plus meals, you are gonna get some money for meals. You're gonna get housing. What I'm saying, this can give you some experience. You can know what research is, because now you are telling me you know, right?
Right. So to look further on this, it's REU.
Yeah, research for undergrad.
Okay.
Summer. Okay, I can show it to you. Oops, I forgot to.